What's up, everybody? We're going to do some angular collisions, all right? Angular, did I spell that right? Collisions. All right, here we go. We have a truck. It's heading north. We're going to say it's 3,000 kilograms. That's a big boy. At 13 meters per second. There it goes. And heading east is a little 800 kilogram car. And it's also going 13 meters per second. All right. Now these guys are going to collide with each other. My first question is, which direction do you think they're going to go? Are they going to go more that way? Or are they going to go more that way? That's right. They're going to go more up than sideways because this guy clearly has more momentum than this truck. Let's calculate that momentum. This guy's 3,000 times 1,300. 3 times 393.9 million P. That's not right. Look at me being crazy. 3,000 kilograms at 13 meters per second. 39,000 P. Okay. And this guy's heading east. 800 times 13. 10,400 P. So what we're going to end up here with, guys, is a new triangle up here. All right, we're going to trig this problem. We have 39,000 P and 10,400 P. So we're going to end up with a triangle up here after the collision, right? And the up side of the triangle is going to have 39,000 P. So we're going to make that length qualitatively relative to this 10,400 P. So this is this side of the triangle, 10,400 P. So now when they come together, they're going to fly on our new angle like this, which is going to be the hypotenuse. This is a right triangle. Since we're colliding at 90 degrees, our collision is going to be a right triangle. So we're going to use Pythagorean Theorem. A squared plus b squared, 10,000 squared, plus 39,000 squared. I'm sorry, it's a little dark in here. I'm having a hard time hitting my calculator. 10,400 squared. I did hit the right button. Times 39,000 squared. Good Lord. 10,400 squared plus 39,000 squared equals square root. So we're going to have 40,363 P. 40,363 P. So this is this side, right? This is this side of the triangle. And you're like, Mr. Perkins, they have more P now than they originally had. No, there's not any more momentum. This is just the way these two momentums combine, okay? So if you look, we know we had this much P, right? 40,363 P. And how much do these guys, when they crash, they stick together. So both of them are stuck together now going this way. So both of them together weigh 3,800. That's their combined weight at blank meters per second. Okay. So we'll take that and divide it by 3,800. 10.6 meters per second. So they're going 10.6 meters per second in that new direction, 10.6. Now here's what I could ask you. What angle is this going to be? What angle will they fly away? With what angle will they fly away? Well, you can solve that using trig. This is, I don't know, we have opposite and adjacent. So we can say the opposite, we'll say the tangent of theta is equal to the opposite side, 39,000, over the adjacent side, 10,400. And we'll say 39,000 divided by 10,400 equals second tan. 75 degrees. So this angle is 75 degrees here, right? Let's try another one. How about we have a truck going this way at 19 meters per second, all right? And it weighs 2,200 kilograms. And we have a car that weighs 1,000 kilograms moving south at 22 meters per second. Now this guy, just by looking, is going to have the most momentum. Don't you agree? So we're going to collide right here. And since this guy is going to have more momentum than this guy, because it's so much heavier and only going a little bit slower, we know that we're going to go more to the right than down. So let's take a look at this. Let's calculate the P first before we make a guess at that. 2,200 times 19 gives us 41,800 P. What is the P for this guy right here? All right, 1,000 times 22. So that's going to be 22,000 P. So this guy's got almost twice as much momentum as this guy. So we're definitely going to go more this way than down, correct? All right, these two guys are going to collide, all right? The hypotenuse is them together, right? This side of the triangle is 41,800 P, because that's this direction, right? And now this side of the triangle is going to be 22,000 P. And that's not really drawn to scale, but, you know, we're all doing guesswork here at the beginning. I guess it's going to look, really would look a little more like that. Don't you agree? I hope you understand what I mean by this. If this is 22,000, that's 41,800. This side would need to be a little bit longer. All right, calculate the amount of momentum we would use for the hypotenuse. Okay, Pythagorean Theorem again. 41,800 squared plus 22,000 squared equals square root. So we have 47,236 P for our hypotenuse. And both of these, the truck and the car, are both smashed together. So what is the total mass in this direction? Yep, it's 2,200 plus 1,000. So that's 3,200 kilograms moving that way at blank meters per second. And we have 47,236 is our total P. So 47,236 divided by 32,000, or excuse me, yeah, 3,200. 3,200 kilograms gives us 14.76 meters per second. And that's about right, because both of them have slowed down a little bit after the collision. So 14.76 meters per second. And now let's figure out what angle would they fly away with. You go ahead and calculate that. You know all sides of the triangle. All right, I'm going to say opposite over adjacent. I'm going to say the tangent of theta equals the opposite side, 22,000, over the adjacent side, 41,800. And then I'll have to second tan that to get the answer, right? So 22,000 divided by 41,800 equals second tangent. 27.7 degrees, or actually 27.8 degrees. All right, I hope this helps.